All right, well, welcome to Intro to AWS with Jupyter Notebooks. My name is Pamela Reynolds, and I'm the Associate Director of the UC Davis DataLab for Data Science and Informatics. DataLab facilitates the application of data science methods, technologies, and best practices to enhance research and learning across UC Davis and beyond. We support research services, training events such as this workshop today, and community efforts to build and grow our capacity in the data sciences. Today's workshop is going to provide an introduction to cloud computing with Amazon Web Solutions, and specifically, we're going to learn about AWS infrastructure and services, as well as identifying good use cases for research on this platform. In the hands-on lab portion that'll be woven throughout today, we'll launch a Jupyter Notebook on SageMaker and APIs to launch an application. We're also going to discuss where you can go to learn more. And I'm going to put in a quick plug that DataLab has drop-in office hours help every Monday afternoon. I'll post a direct link in the chat. And our lead instructor today, Kevin, has graciously offered to show up for our next office hours this coming Monday on 8/24 in case you were playing with this after today or you have any follow-up questions that you forgot to ask. So with that, I'd like to introduce our instructors. Kevin Murakoshi is a Senior Solutions Architect at AWS, working with the Northern California UC School specifically. Prior to joining AWS, though, Kevin worked at UC Davis in IET, where he supported a wide range of tools from critical campus infrastructure to research IT. So he's very familiar with the space that many of you are coming from. He's joined today by his colleague, Claudiu, who previously worked in supercomputing as a research scientist at UC San Diego, and Danyell, who specializes in working with the UC academic medical centers. So if you have medical-focused questions or medical data that you're working with, he'd be a great one also to reach out. And you'll see that both of them are on the chat today. So if you have a question that you want to direct to someone specifically in the chat, you can go ahead and tag them with their name. Otherwise, all of us that are hosting will try our best to answer. And just as a note, because there are a lot more of you than us on there, our lead instructor, Kevin, probably won't be able to see all the questions on chat, so we may occasionally interrupt him and help field some of those questions if they're consistently coming up over time. So don't worry if we don't get to you right away. There sometimes gets to be an influx of questions that takes us a little while to get through them. All right, so with that, I'll kick it over to Kevin, and thank you again so much for coming to share with our communities how they might be able to hop on and use your platform.
Cool. Hi, everybody. It's always awesome to come back to Davis. Since I still live in town, and with all of the fire outside, this is a nice escape. So I want to get quickly started here. So we're going to kind of do this in a couple parts. We're going to start with kind of a talk about AWS in general and security in particular in AWS, and then we're going to jump into this, the lab. The lab is a couple different parts, and it's going to kind of go through most of what we'd call the core services. So identity, compute, storage, and networking. After that's over, we're going to look at some kind of research use cases for AWS, when you might use it, how it might be used. And then we'll end with a bunch of stuff on resources for UC Davis researchers. So all the labs are going to be in your browser. You'll find a temporary account credential today. Please let us know if you have questions or there's issues with that. So AWS is a platform that lets you do lots of things, right? And it's really, it'd be nice to reach for a number of places, right? First, it lets you kind of not deal with managing servers or boxes or machines in your office. A lot of researchers have compute clusters on their offices, or they've kind of have to cobble stuff together out of parts. I knew a guy in chemistry who actually had two HPC clusters in separate fume hoods, a room apart, with data cables running between them. So this gets you out of having to manage that kind of stuff, right? You can collaborate across the platform. If lots of people use it, they can share data and share infrastructure. This lets you use automation to reproduce your research, or reproduce the workflow that you use to build things. And then we've got lots of really kind of advanced analytics and machine learning tools that you can take advantage of. And finally, AWS can offer higher security than most campuses can provide. And for example, Davis runs a NIST 800-171 compliant environment. That's a federal CUI data area in AWS. And UCSF has a HIPAA environment in AWS because they're places that they can put higher security controls in some cases. So AWS is we've got a global network, right? We've got this huge reach, and we've got 24 availability zones, regions around the world, which lets you really kind of use compute anywhere it's available, anywhere you need it. within this idea, we have this idea of regions, and a region is a group of local data centers or availability zones that are kind of in the same general place, but each AZ is separate from the others, usually separated by disaster zones or other, like different power grids, that kind of stuff. So that you're not sitting on one particular location. Each AZ is made up of more data centers, which are in that area. So if an AZ would, if you were to lose an AZ, you wouldn't lose the whole region. And this gives us a way to have really strong, sorry, I need to not look at the chat, I'm sorry. I'm just gonna close that. Gives you a way to make sure that your data never gets lost, right? There's always redundancy, and there's redundancy across lots of areas. We also have a large, really large and broad functionality, ranging from everything from like infrastructure services to machine learning tools and media tools. We have a satellite operations tool for the complete edge cases that are there. But there's lots of stuff, and AWS can be very intimidating to get started with, and that's kind of what the role of the SAs are. The student architects are kind of roles to help guide you through that process and make this giant picture look a little less scary. So AWS security, we talked about security, I want to kind of make sure we talk about how security works in AWS. So in a general sense, AWS is also for the security of the cloud. That's the kind of the physical locations, the underlying compute, storage, networking that the cloud provides. But customers or users are responsible for the kind of their data, how they access it, the operating systems they install on it, and the encryption they put on there. Just because you use AWS doesn't mean you're secure by default. It does mean you have a responsibility here to work to maintain your data. That's why campuses have built secure research environments or secure environments so they can provide that extra layer of security for campus users. It's also important as we kind of look at this, we want to think about this in terms of kind of services. So AWS offers service at multiple levels. We offer pretty like basic infrastructure service tools, right? Just a computer, at which point we're going to manage the physical equipment and the software, the networking, the hardware, all of that kind of stuff. But as a customer, you're responsible for the application code, the scaling, all of the configuration, all of that stuff. But we also provide services like container orchestration, where we manage a little bit more, right? The container control plane is something we manage. To kind of a managed container service where we have, we control more of the scaling of the other things, and then a kind of a fully serverless service where we manage pretty much everything and you only have to deal with code. One of the really big advantages of using AWS is to get into the space of using these serverless components. They get you out of having to maintain and manage software and hardware that you don't have to. So much research kind of ends up being, you cobble this thing together and you hope it works, and then when it breaks, you spend a lot of time fixing it. This takes you out of that job. You just have to deal with the code or the tools that you're responsible for, and not like hacking together a bunch of servers to make sure they all talk. This is a kind of a big picture compliance space. We comply with a lot of different federal and non-federal compliance standards. So if you have features that require something like FedRAMP or NIST, CUI, or as PII, we've got a lot of backing to kind of manage how that security works in our cloud. And probably have approval for that data. If you do have workloads like that, please reach out to us. It's one of Danyell specializes in medical centers for PII and HIPAA, but there's a bunch of stuff there where we can offer to help those things. So one kind of important thing though, it's still always your data, right? You choose where your data goes. Each region is geographically isolated, so data doesn't move around the world, right? So if you put in AWS, it doesn't mean that your data is suddenly going to China. Your data will stay in that region that you put it in unless you tell us to move it somewhere else. You're gonna own your data, you can encrypt it, you can move it, you can delete it. If you really, we treat that as your data, and even SAs like us don't have access to that stuff. We have no idea what's inside your account or what the data is. I think that this is an important kind of talking point. Reproducibility is a big issue in research right now. Without looking at kind of, is it a crisis or not, it's really important. We provide a lot of tools to automate infrastructure to make it easier to deploy. And when we think about this, code is more reliable and audible than people are. And so by generating code, instead of doing things by hand that lets you repeat it, it also lets you share it. So you can share the entire infrastructure you use to do your research with someone else, and they can repeat the same calculations, right? They can run the same model. And that makes this, that's gonna be really valuable as you work with these kinds of tools. You don't have to kind of walk the next grad student through the process of setting up what you set up because you're about to leave. You can have this written out as code in some way, and they can deploy it. And they can delete it when it's done, so you don't have to worry about it not being there. As long as it can be recreated, you can destroy it and not pay for it, and only pay for it when you need to use it. All right. So with that said, we're going to kind of get started with the lab here. In this lab, we're going to do kind of 5 things, really, and the 6th is optional. We're going to create we're going to launch a notebook, a Jupyter notebook. We're then going to create a bucket and copy a file to it. We're going to create a networking environment and launch an instance. So before that, I have to show you. This is the unfortunately manual step here. I'm going to put this on the screen. Let's see here. Okay, I need everyone to, on this list, find their name and copy down the rather long, annoyingly long hash number. Actually, wait, we'll stop. Let's do this in a different order. We'll do this way. Okay, so I want everyone to go to this URL, dashboard.eventengine.run, and you'll see this kind of black page when you do. I'm gonna wait a couple minutes for everyone to get there. If you could, in your status, put a check, hit yes on the participants window when you're here. I will also paste it into chat. Can someone paste that into chat?
This is a reminder for these quick yeses or nos. Please use the action items. That's the yes, the green checkbox, and don't type it in the chat. So where are the action items? Yep. So if you go to the participants down at the bottom of Zoom, there'll be the 2 little people symbol. If you click that, it'll pop up on, for me, it pops up on the top right. You'll see yes, no, go slower, go faster. That's where you can click the yes button. Great, looks like about half of you, just over half of you are there. Okay, Kevin, I think we're starting to get questions about the hashes. So I think this is time.
We're gonna get there. Yep. All right. Okay. So another URL you have to get. So you're going to see this little screen with the console login. Click on the Open Console to access your temporary AWS account. And then please download the lab guide here at tinyurl.com/DataLab Jupyter. And if someone can paste that in chat as well, that'd be helpful. Thank you. Once you get to your console, this is what you're going to generally see, right? You're going to see kind of, it's a web console, there's a GUI, right? Your user's up here, your region is here, and that's kind of all we need to start with. Services, there's services, and there's your service list. So the first part is going to create an IAM role. And I think before we get started, I'd like to we'll talk a little what IAM is and what it does. IAM is those systems that kind of let you control the access control within your environment, right? It gets to who can do what with your account from where, right? You get fine gain control with your two-factor auth. You can integrate single sign and lots of other stuff. In IAM, there's IAM users, which is an individual system or application that has to access it, right? It's got a unique name or credentials, and it's a password or key. IAM users only need passes when they access the management console. Usually they get access keys. IAM access keys make programmatic calls to AWS. They look like this. Maybe you can get, we're not going to need them today, but you'll see these if you start using AWS APIs a lot. And then there's policies. And policies effectively say, what are you allowed to do? What allow or deny? On what action can you do? And then on what object can you do it? Right? And that's a general idea. And IAM roles are really important. IAM roles it's kind of like a user, but it's an identity that you give to some AWS service to do something on your behalf. And we're going to do that a lot today. So we're going to use on Jupyter Notebook is going to be able to issue AWS calls, or API calls on our behalf. And so we have to grant a role to our notebook to allow it to do that. And so let's go take a look at our console here.
While opening, just to clarify, you have to give permission to any entity. It could be a user or a piece of code, virtual machine, Lambda function, to be able to do any kind of action on your behalf in your account. Otherwise, it doesn't work. So if you saw in that screen, there were secret keys those are used as alternative credentials in our programming against the APIs that AWS offers.
All right. So here's our console. Does everyone have, and we have a lab, we have the lab guide, right? So everyone found the lab guide? So I'm going to start with creating this role. So we're going to go here, type in IAM, or go to the link. And we're going to go to roles and click create role. And we're going to go look in this list. So this screen has kind of the what kind of entity, AWS service, another AWS account, some federation, and then what use case do you have? And so we're going to go down here and find SageMaker, which is over here.
And Kevin, really quickly, for those who aren't familiar with SageMaker, what is it?
We'll talk about Sage. So SageMaker is our machine learning service, but we're gonna get into that a little bit in a little bit. So just for right now, assume that there's a thing here that you're gonna click on. Take permissions. And there we go. We're gonna accept all that. View it, and we'll give it a name. Let's see here. I'll do something like that. And create. All right. As a very quick show of hands, has most people gotten there? Click check if you do. So the couple people may have had some trouble here. So in this case, when we give you this account, you're the administrator. You're a full user. You can do anything in the account. So you can create roles when you as soon as you get there. Let's see here.
So what step are you in the guide?
I am on step 7 in the guide.
No, I was
Just
asking.
fin-
We have a couple
Oh,
users who are stuck, so I'm trying to figure out where they made it to in the guide. So maybe I could get some guidance.
Oh, okay.
Okay.
In the upper left corner, click on the services, right? And then click on, then type IAM or find IAM or type IAM here. And then you'll get to the IAM main page.
Yeah, do it again. Just create another role. Doesn't
Yeah.
matter.
Yeah, let's just we
Repeat
create
the
a second
We'll
row.
start over. Yep, so when I clicked on that, I got to the IAM console, that's this thing. I click on roles on the left. I'm gonna create a role. And I'll find the SageMaker. I'll find in this list, I'll look till I find SageMaker. Click on SageMaker. Click next. Click next. Next. Then I'll give it a name. And I will create that. And then I'll search for in this list and it will show up my 2 roles.
Just as a quick note for those of you as you're following along with this, we know these are unprecedented times, so we may lose power, you may lose power, internet connectivity may go down. We are recording, so this will be posted later. And also, the lab guide does have step-by-step through what Kevin is going to go through today. So if we're going too slow for you, feel free to just go on your own pace and then pop back in when you have questions. Otherwise, we're going to walk through those different steps today.
Okay, cool. So now we have to give that our role some admin rights. So we'll click on the role, and attach a policy. And we're gonna go look here, we're gonna find the one that says administrator access. And we're gonna attach this. So this means that anything with this role can do basically anything in the account. In a fully production web, this may not be the best thing because now you're letting something be you. You might want to scope that more granularly, but for these labs, since we want to play with a lot of different services, we use the administrative access role. And there we go. So, okay, now we're going to launch the SageMaker instance. So let's talk about SageMaker. So AWS has a pretty broad machine learning stack, and it covers everything from kind of pre-built models to building models to kind of the underlying frameworks. We're going to be focusing on SageMaker, which is this piece here. And SageMaker is our kind of our machine learning service. It can do a lot of stuff. Everything from kind of managing data sets and workflows to having notebooks to doing training, debugging. You can run experiments and training runs and do all sorts of other stuff as well. Right? But for what we want to do is it comes with a service that lets us run Jupyter notebooks. And so we're going to use the SageMaker notebook service to run our notebook in, right? It's easy to sign on, it's a managed service. It sets up really quickly, and you can share across AWS accounts very easily. So, that in let's go do that piece now.
So while you're doing that, again, SageMaker, it's a much larger platform. It has lots of features. But for the interest of time and just to keep things simple, we're only using the built-in notebooks, which are Jupyter notebooks. All the other features can be subject of another workshop if you want, machine learning and AI. But for now, just sticking to how do we get really quickly a Jupyter notebook in AWS with minimal fuss? And SageMaker is your friend here.
All right, so services. Find the type, search for SageMaker. And then we're going to go find on the left notebook instances. Okay. I want to see a quick check-in. Are most people kind of around this place? Yes, no. Yeah, I see.
You can click the yes or the no button. If you think we're going too slow or too fast, again, there are other buttons as well you can choose. Just let us know your feedback. How are we doing so far?
Okay. So I'm going to go back a couple steps here. So we should have been here at the end of the last step. We have a role and we gave it some rights. So we're going to click on the upper left. There's a little thing that says services, and it'll bring up this screen. And we can type SageMaker into that. And once we do that, this will pop up, and we can click on that. That'll get us to the SageMaker console. From here, on the left, there's a bunch of different services. The one we want here is the notebook instances one. And we'll click. There. Okay. And I think most people are here now. We're going to click on Create Notebook Instance. And we're going to give our notebook instance a name. Say, you can pick a server. This is leave the default, but you can pick any number of things here. And then the role, we're going to pick this SageMaker admin role that we had created before. And this is the piece where we need to have a role created. I'll zoom in a little bit so let's just see. And once we have that, we'll just create. And this will take a little bit. So while that's happening, I'd like everyone to go to this URL and download the Jupyter notebook that we're going to use. I will paste that in the chat as well. Or someone will paste the chat. Oh wait, I think I'm sharing the wrong screen there. Here it is. This URL, tinyurl.com/DataLab notebook.
And while Kevin is orienting for this next part, just as a reminder to go ahead and hit the no button if you need help, and then we're responding to questions in chat. And there is the breakout room if you're really, really stuck and you need to just chat one-on-one with somebody. But let us know before you go there so that we can make sure there's someone there to chat with you.
So this section, so let's go, we're gonna head back to our console here.
I can't, that tiny URL is not working for me, Kevin. I
not
see other
working?
people
Okay.
are having instances,
Then
having
let me,
issues.
yeah.
Probably because it's oh, well, I'm using Firefox. It might work in other browsers.
Which, well, let me double check here. It's entirely possible that I typed it wrong.
I just pasted the non-tiny URL link that's working for me.
Oh, okay. Thank you, Pamela. Yeah. Cool. Thank you. Oh, that's, oh, sorry, it's a different URL.
I posted the wrong thing. Sorry, that's not helpful.
Here we go. There's the notebook URL. So we want to wait till this is running. It's still taking its sweet time here.
So I think quick questions. Which elastic inference should we choose?
You shouldn't have to choose that. Let's see here. Hold this up. Yeah, all you want to do is on the notebook, just pick a role and don't change anything else.
Okay.
There are lots of other things you can set up here. I don't know where you get here. Yeah, you can there's lots of stuff you can set up and add to this, but still not working. Can I upload a?
What's not working, Rashmi? Are you able to?
I'm not able to open this link. There's something wrong.
Okay.
Which one, the Python?
The one just Kevin pasted?
So that link you have to save.
Yeah, I did save, but when I try to open, what is the application to open that?
You don't open with an application. Actually, you will upload it right now into SageMaker in the next steps.
Oh, okay. Okay, thank you.
So there is no need to open it on your actual machine. It's primarily a text file, contains Python code and some descriptions. Looks like a JSON.
Yep. Okay. So once you're going to see your status go to green and see in service, and then we'll open Jupyter. And this will pop up. And you can upload that file you just downloaded. I gotta go.
You're not sharing that. We see the PowerPoint with the S3, so go back there.
Thank you, Danyell. Yeah. There we go. So here we go. Look on Open Jupyter.
You have to have the Jupyter showed as in service with green.
In service. Here. This has to be green. If
it's not in service, you can't open it. Let's just wait until everybody's at this page. So.
Yeah. Yep. If you get here, please click yes.
Yeah, it takes about a minute to create a notebook for you. afterwards you should be able to use it. It should show in service.
So, and then while we wait, I think let's talk a little bit about the first service we're gonna play with here. Yeah. So the first thing we're gonna do is create an S3 bucket. And Amazon S3 is our simple storage service, right? It's a web accessible object store. In fact, it's where we stored the lab guides. It's got 11 nines of durability, which means there's in the 9 with 99.999, it will always be a chance that an object will be lost, right? It scales infinitely, right? And it comes in lots of different flavors. You can choose kind of the storage, how your storage class, which kind of talks about you can start with our basic storage, which is frequently accessed data, and move as you access it less all the way down to something like Glacier Deep Archive, which costs about $1 a terabyte, but might take 12 to 40 hours to recover the data back. This is really good for data that's archival. You finished all your work and you need to put it somewhere. You don't want to lose it, but you don't really need it very often, if at all. And you can use kind of these tiers to handle where you put stuff. So S3 is, it's parallel I/O. It can work very quickly. You can have level permissions in IAM down to the resource level, so you can say this thing, you control who has access to it. You can also use policies to control who has access to objects within the bucket, and you can access directly with APIs. You can encrypt the data. You can host a website on it, and you can use rules to move data out into archival things as it gets unused. So you say after 30 days, I don't care anymore, move it somewhere else. And finally, you can use a service called Amazon Athena, which lets you query data that's in S3 in certain formats as standard SQL. So if you have a bunch of CSV files, you can go query those CSV files as if they were a database. And this is really useful for where you have lots of semi-structured data that's just sitting around. And you want to be able to it's too big to really handle in Excel, but probably too small to pay for running a database all the time on. And then this makes it very easy. You only pay for the data you read, and you pay by the gigabyte, by the terabyte read, the gigabyte you read out of it. You also have things like Glacier Deep Archive. These are the kind of low-cost archival storage options, right? They're designed for 11 nines of durability, and they're designed for archival solutions. So therefore, you have to pull the data back. It might take hours to get data back, but it can be very, very cheap. This is more for afterwards. This is kind of a big thing about all the different features of the different classes. All right, so I'm gonna go, most people should be at the notebook step. So let's go back to our console here. All right, and now that we're here, we're gonna click on the Open Jupyter and upload. We're gonna upload the file we downloaded here. And then we can launch our notebook. Now we have our notebook. All right. So if you're here, let's see here. I think I'm gonna keep going here. So this is generic, pretty normal Jupyter. So okay, let's run that. This is gonna load all the, and then the next command is gonna use the S3 bucket API. So I want to be clear for, I want to talk about kind of what the goal of this notebook is. The goal of this notebook is not specifically to do a bunch of compute on the notebook. We're using this notebook as a way to explore using AWS APIs to launch AWS, like talk about AWS core infrastructure. So what we're going to do with this is create a bunch of AWS resources. And then the first one we can create is that S3 bucket. And this is a relatively simple API call, but you can create this bucket and okay. It'll create a bucket. It's going to give you a return the bucket name. Now, AWS bucket names need to be globally unique. They have to be unique across all S3 buckets in all of AWS. So we have to, the first piece kind of generates, so it uses a random, your UUID, to generate a unique string for your bucket name. Okay. So, quick switch back here to talk a little about VPCs. So VPC is our virtual private cloud. It's kind of our networking abstract concept in AWS, right? A VPC has subnets, and the subnets are tied to an availability zone. Remember the availabilities we talked about in the beginning. We deploy instances or things in those subnets. So when we run a server in AWS, it has to live in a subnet, in a VPC, which is in some availability zone. This is especially important when you do things like HPCs, where you're building kind of machine learning, you're using like underlying hardware and building clusters and stuff like that. You need to have kind of some concept of where the stuff is actually sitting and where it needs to be talking to. So going back to our thing here. This kind of block of code, which is a little bit long, is going to create a VPC, create some subnets, and then create some route tables to route the traffic properly. And it returns back the VPC and the subnets that we have.
So networking might not be your strong point, but this is really one way to which you actually have code written that creates pretty much a data center, a virtual data center for you in AWS with the respective networking settings that you want. And this is portable because you can give it to another researcher and they can get the exact same setup. And you can have, one more 100 machines in this virtual data center that you create, and they can replicate the exact same setup virtually, of course, in their own account with just a couple of lines of code. So what Kevin is showing here, you can also do from the console, but it just takes a lot more time and it's more error prone because again, click here, click there, and you can actually see right now in this virtual seminar, how long it takes to get everybody on the same page and walk through click here, click there. So again, assuming you're doing this via email and you tell your coworker, go there, do this, it's going to be a lot more error prone than just writing that code and then giving them the code and they can run it and see the exact same results.
You can, I'm not gonna, you don't have to go do this, but you can go see that it created these things if you go look in your VPC in the console, we can see that it creates stuff. It creates a route table and a bunch of other resources here as well. Okay, so now we're gonna create a web page. Right, this is just write a file that says hello world. We're gonna then copy that file to S3. And if we go look at S3, we can see our bucket, and we can see the file that we created here. And if we really wanted, we can download a copy of that file.
Hey, Kevin, do you want people to be following along with what you're doing right now?
Ideally, yes.
Watch?
Okay.
Okay.
This part, no, don't follow this part. Don't follow this part around. You can if you really want to go digging, but I wanted to show this is there. I don't think you have to go and try to navigate everything really fast. This is just a way to kind of see that it did something else. So then the next piece is the security group. We're going to create a security group. And security groups are like virtual firewalls. They sit around a compute in AWS, a server, and act like a firewall and they deny all traffic, and then you have to explicitly allow certain kinds of traffic in. So this is a web page. We have to allow the web traffic through the firewall. So we're going to create that rule, and then we're going to allow these ports 80 and 443. And you don't have to know this. This is just if you want to see it, but it's going to allow the HTTP, our web browser, to reach that server. Cool. So now we get to talk about the EC2. So AWS has a number of compute services, and we're starting with EC2, which is the basic one. Which provides virtual servers. We also have services that offer containers and serverless computing as well. EC2 is, can run Linux and Windows. It can run ARM x86. It's got lots of different options. You can do everything from kind of general purpose to like specially optimized for high throughput or GPUs. You can use images, AMIs, which we'll talk about in a little bit, to kind of package software. For example, for those of you who need RStudio, there is an AMI package just for RStudio. You can deploy that, and you'll get RStudio running without having to do all this setup and installation. It also lets you share artifacts. If you have a researcher you want to share something with, you can build a machine image, share it with them, and they can deploy exactly the same machine, the same OS as what you were running with all the software already installed. This is particularly valuable when you've got stuff like, you've got a lot of different packages, a lot of research components that you have to get just working just right. And then you have this ability to share a fully working model with someone else and not a list of instructions on how to build it. So we have lots of instance types that range from kind of general purpose instances that we're using now to kind of, optimize. So with lots of compute, lots of memory, with GPUs or FPGAs, and then for high I/O use, if you've got a lot of high I/O workload. We also offer both Intel, AMD, and ARM processors. AMD and ARM are generally much cheaper than the Intel processors, so if you have a workload, they can be you can want to look there and see if you can get a cheaper processor for the same kind of system. We have a number of ways you can pay for it, and this is really important if you're trying to save money. You can pay on demand, which is what we're doing now. You pay for capacity by the second, and you can turn it off when you don't use it. That's great, but it can be a little expensive. To save money, you can either commit to a large amount of to a whole year. This machine's going to run a whole year, and you get up to 73% discount on that system, or 1 to 3 years, I should say. You also have spot instances, and spot instances is the spare capacity in our environment that we have. So we build capacity to always be there enough capacity for you to use it, and there's always some spare capacity sitting there usually. And so you can use spot to pay up to 90% less for those compute resources, with the idea that we might say, we need that service back. So we might give you a warning, say, hey, this box is going away. So if you've got a system that's easily reproducible, or where you can kind of stop and start it a lot, Spot's great. So it tends to be really used for HPC type workloads where you have trivially parallelizable jobs, and you can just do a little bit at a time. And if a box goes away, you can run another one and rerun that compute, and then you're done. So yeah, Spot is really nice. It's fast. You can these are the kinds of things, big data simulations, HPC, where you've got cases where the machine doesn't matter as long as there's enough there to kind of meet your needs. Here's a list of the OSs we support: Windows, Linux, a bunch of different Linux versions, and there's a whole list of these. Okay, let's go back to our. Okay. So at this point, the first thing we need to do if we want to launch this is figure out what machine image we're going to run. And this code here searches for the most current basic Amazon Linux AMI. So we want to install a web server, so we've got to write some code, a script to do that, and we're going to save that here. And then we're going to, because the way that we pull the APIs work, we want to base64 encode that file. So we're going to base64 encode that chunk of data, that file that we just created. And then we're going to launch an instance. And this piece is relatively straightforward. But what it's going to do is it's going to launch the AMI we asked for. We're going to launch one of them. If I wanted to launch 20, I could just change this number. Of a certain size, in this case, the M5 large instance type. We're going to have enhanced monitoring so we get more data about what it's doing. We're going to supply our user data, that this script that we provided above. And then we're going to get it set up its networking. And we're going to give it a name as well, right? In this case, we're trying to tell, we wanted to get a public IP address, and we wanted to put it in, we're going to tell it what network it should be on and what security group it should have attached to it. Cool. Now, it's been launched. So don't have to follow me here, but if you really want to look, we can see that something has happened. But it takes a little while for the instance to spin up. And you can see that it's kind of running, but it's still kind of getting ready. If you hit the next command, this command waits until the instance is fully running. And mine is already up and running. But it will wait here until that instance comes fully online. So now my instance is online. It's mostly ready.
Hey, Kevin, where do you check all these, like, where do you go to this page? Like,
so if you wanted to go here, the service is called EC2. So you go to services and find the EC2 service. For right now, because we're doing it with Jupyter, you don't necessarily have to go look at it, but that's where you would go to look at what the instances you're running at any given time. So these services, EC2, and then you want to look at, there's lots of stuff here, but you want to look at instances to see kind of full server kind of sitting there getting ready. Here we go. It's running. It looks like it's up. It also has a pub. You can kind of find out information about it. And then if the next one, you can kind of print this. This will actually give you a link to go look at your instance in the console. And if you click on this, it will pop up a web page that says, I can talk to the machine. There is a bug in this lab where the file that we created and put in S3 doesn't get copied properly. I'm sorry, we're going to fix it. So you just get this kind of generic page. And that's it. So now you've built a network, you've built a bucket, and you've launched a server. You can replace that server with anything. I know there's a lot of cases people might want to launch something like RStudio, or you want to run a number of other kinds of compute jobs off of it. There is a section here about how to clean everything up. I'm not going to run through it right now because I think that way people can kind of see it. Can have a chance to play with what they've got afterwards. We're going to leave the labs open for a couple hours after this session ends. So if you want to keep playing, you can keep playing with those resources, and they'll be turned off automatically when the time expires. So you don't have to worry too much about stuff sitting there. But this will remove all the things we just built.
And I'll jump on and say that's important because depending on your service model, you could be racking up some costs if you forget to shut it down when you're done.
This is another very important thing of AWS. You do not want to keep it running if you're not using it. Turn it off when you're done, and you won't get charged for it because you only get charged when it's turned on. In this case, we're actually going to delete everything. So not only are we going to stop it, we're going to delete everything. You can just stop the instance, and then you don't charge for, you still pay for storage and other things. So this will delete all the resources that were created today.
In the previous version we did we were actually running some of these through the console. Now, for those that attend the previous one, you can see you can achieve the same objective just by writing Python code and using the Boto3 library. So if all you know it's Python and Jupyter, you can still come in and write a couple of lines and you create entire data centers and web servers and everything in the sun with just code.
Yeah, so this is one of the really powerful parts of AWS. We can do things the way we did in the beginning, everything by hand. You've got to go find the right screen, you have to click on the right buttons. It's relatively easy if you just click around to find things eventually, but you can't reproduce it twice. I'm just trying to get everyone here to go on the same time and do the same things is tough. It's error prone, it takes a long time, right? And then we can do what we just did here. We scripted everything using Python. So everything is run, everything is created as a script, the call makes API calls and you can do it really quickly. And it's much easier. The second half of that lab when we were working the Jupyter notebook was way simpler than trying to do it all by hand in the beginning. But we've got some more kind of options on top of that. We can use declarative languages like CloudFormation and Terraform. And these are languages where you basically have a file that describes all the things you you want to have happen. And then you let an engine generate those resources. It's a little more shareable. It's a little simpler than having to fill out all those APIs. And it can be very powerful when you want to share easily because you don't have to have permissions. Everyone can take it, go and run that same piece of code, right? However, it's easy to automate and reproduce as well, but the syntax is a little ugly and there's no abstraction. So you have a lot of details. So just creating that VPC we did today is probably a couple hundred lines or so, a couple hundred lines. There's some people who worked on this to make this better. The problem with declarative languages, there's no logic, so you can't make a choice at all, basically. So we have some document object models which put code on top of the API, the CloudFormation and stuff like that. That means if statements, for loops, you can use an IDE, but there's no abstraction. And so if you want to just create that VPC we did before, which was a few 20 lines, it's like 200 lines of code. And the last one that's come out recently is CDK. And CDK allows you to has built-in abstractions. So it's real code, like the document option stuff, but so you can use all the normal things, but it also has constructs that let you take normal defaults. So this one here, this whole piece builds a VPC. And it basically there's a standard VPC and then we modify certain things in it. And that's kind of the power here is that it's easier to script. And you have a number of languages you can do this in Java, Python, C#, JavaScript, or TypeScript. All of these are options, and it comes down to what you feel more comfortable with, right? For a lot of times, the scripted solution is great. It's simple. If you understand Python already, you don't have to learn anything new. Just do stuff that way. If you want to try one of the other layers, you can go up the layer and try harder, try the more abstracted solutions. If you're building very large things, often you want the more abstracted models because it's harder to script out all the commands you're going to run. You want to be able to describe them all. And you get lost trying to script everything. So with that, Pamela asked when should you use AWS? What are the kinds of use cases that would make you think about using it? So we have three basic ones. We've got, I need more capacity than I have. And that can mean I have a laptop, but the big box under my desk in the office I can't get to because we're all remote right now. We can't go to the office. I need a bigger computer to do some simple compute job. Or that can mean I have an HPC, but I need even more HPC. You also have places who want to use our analytics or machine learning tools that are built on top, that are pre-built, so you don't have to manage machine learning models, building clusters yourself. And then also, occasionally you want to work in AWS because the data is already there. You don't have to spend time moving data back and forth. Right, so you can you can change your compute resources to match your workload. So you don't have to play the game of trying to figure out, well, I've got this computer, how can I do this computation with this computer I have? Say, well, I have this data. I need this kind of computer, find a computer like that and use it. We have a number of HPC specific tools. So you can boast out and you can take your machine learning model. I need more capacity. I can use AWS and we can talk to things like Slurm and other HPC tools to boast out more capacity than is currently available in your existing environment into AWS and get it just where you need it and then turn it off when it's not being used. The other use case that I think comes up pretty often here is the kind of these kind of these AI services on top here. So these kind of machine learning and AI services, right? So if you don't want to get into the kind of nuts and bolts of building clusters by hand, no TensorFlow, building up, hooking everything together, building clusters out of servers, you can use SageMaker, which lets you kind of abstracts that out, and you can use our tooling to help set up your clusters, help manage that. It even has tools to kind of debug machine learning models or compare different algorithms to see which one works better. But even then, if you say you don't want to deal with machine learning, but you've got some work to do, we have a number of AI services that are useful. They range from things like recognition, which is a computer vision model. So let's say you've got a bunch of pictures and you want to see all the ones where someone's got, like, there's a car in that picture. You've got a big pile of things that were taken over a number of years at some research site. You can use recognition to go and analyze those images. You can do facial recognition, look for the same faces. You can look at stuff like expressions, those kinds of things. If you've got a bunch of audio, you can do stuff where, let's say you have a number of years of archived video that has audio interviews with someone, and you're an anthropology major, or someone that the broad space. And you need to you've got this in there. Normally you'd have to find some undergrad to sit there and transcribe all this video. And so it's too expensive to ever work with. We have a tool called Transcribe, which can transcribe that audio in the video, the audio part of that video into text. It's not going to be perfect. If you ever work with machine transcription, it can be a little rough, but it will get you to a place where then you can do work on it. You can actually search it and things like that. Even if it's not 100% right, that will give you a whole lot more than you would have before, which was effectively nothing, or pay someone to transcribe it for you. Similarly, stuff like we have text, and we also have things like text draft, which lets you take documents and PDFs or images and transcribe them and get text out of them you can search. So if you've got a bunch of old forms that were filled out in the 50s that were typewritten somewhere, but you don't have a way to search those, you can use our text recognition service to do that, and you don't have to build any machine learning to do that. TextWrite does not currently support Arabic, unfortunately. Let's see here. Similarly, we have a bunch of analytics tools. We kind of mentioned this kind of stuff, but if you have things like EMR, Spark and Hadoop, kinds of jobs that you're doing on data already, you can use our tooling to not have to deal with managing Spark clusters or Spark Hadoop clusters and all of that stuff. You can use tools like Athena to query CSV or kind of semi-structured text like JSON as if it was SQL. So it gives you more analytics, more power to analyze the data that you've already collected. And then finally, when you work in the cloud, the traditional model is you have some data sets that are available somewhere, and you spend a lot of time moving large chunks of data from the person that had it before to your environment so you can work on it, and then moving it back when you've got some new data, you've got some new artifact. With the cloud, you can move your computing resources to your data. You can put all of your data in AWS, and then find then get compute resources, whether it's machine learning or EMR, other kinds of things directly to work on that data set without having to kind of spend a bunch of time engineering how you move data around to different tools. So last section here. We went a little early, but it's okay. So where to go from here? First off, UC Davis has a product called Aggie Cloud, which is running out of Central IT. That kind of has a centralized built-in authentication model, so you can log in using your UC Davis CAS ID. It also offers an 11% discount on all services in the account, which is pretty valuable if you're trying to use AWS. And you can send an email to IAT to get information about it. For people who use NIH, there's a program called Strides, which is available for NIH-funded faculty, that gives a 9% discount on AWS services. Right, one of the goals is to create large data sets that can be used across researchers, and there are some eligibility requirements. But if you have NIH data, it's worth looking into for working on your research. to people who have NSF-based funding. People that receive their cloud allocations who can get it, they can get their money through Cloud Bank. They'll also receive additional services as well, and this can help get out of having to pay indirect costs on the cloud service for those grants. We have a research webpage that's on the bottom here that is specifically focused on research workloads. So if you have if you want to go look and find resources that are research specific, this is where you go to look for them. We have a number of quick starts, which are these are sample environments that you can spin up using CloudFormation templates that will spin up an existing workload resource or environment or kind of thing for you, right? We also have training pathways and kind of blog articles for things if you're interested in looking at using research for AWS. There's an open data registry in AWS that has a number of very commonly used data sets. And we're always open to people adding more. So if you work with a data set that is got pretty wide availability, please talk to us. We can look at hosting it. If it's hosted in AWS, you don't have to pay for storing it, nor do you have to pay the cost of people downloading that data set. This is particularly useful if you're interested in getting used to AWS. We have a research kind of a training pathway that covers a lot of the services that researchers might use. And that is all free. So this gives you kind of a set of common research-focused services that you can go take training on and learn about without having to trying to figure out the things you need to train. You like find all of these offerings, and that's available at this link here. So as UC Davis students and faculty and staff, UC Davis is part of the AWS Educate program, which provides kind of self-paced learning, AWS credit, and then some other job and related stuff. For you, it's about credits. So you get $100. You get $100 in credits every year as for being part of Educate, and you can go look for it. And that gives you a place to start. So if you're thinking of starting out and you want to try it, but you don't want to pay a bunch of money, you can go use Educate and get some credits, and then start trying stuff out. If you're faculty, you get a larger number of credits. And so you can do other things. You can do a little bit more work with it. And we're going to end with some links to kind of this kind of stuff. So some other programs here. We have AWS Cloud Credits for research. So if you have a research project that you think you might use AWS on, you can reach out to us through this process and apply for credits. And we can give you credits to offset some or all of the AWS spend of your project. There's the Global Data Egress Waiver, which is less critical, but AWS generally charges for egress for data that leaves AWS. Under this program, we waive most of those charges for people. If you do machine learning specifically, there are specific research awards just for machine learning. And there's open data, and then there's some additional notebooks. That's it. So before I end here, there's this link on the bottom here, GitHub, the samples. If you're interested in doing another kind of something else with your Jupyter notebook, these are more workshops that are similar to the workshop we just did, in that they're delivered as Jupyter notebooks. Let's see here. So there's on a number of different topics. We did the kind of most of the basics workshop today, but if you're looking at data lakes or TensorFlow or Batch, which is kind of HPC, you can try one of these other workshops here, and you can do that within the account you used today. And with that, I think that's the end of this content. So I think time to open it up for questions. I know that there's been a lot of questions in the chat. And I'll be at office hours on Monday.
And before we take into questions, because I know some of you might start dropping off, I'm going to paste the link here into the chat for a brief survey. There will be some fabulous virtual prizes that we will share for those of you that complete this. We'll also circulate this through email, but it really helps us improve our programming, especially as we're transitioning to online. I read everything that you guys write, so if you don't have anything else to say, put a funny joke in there for me. It'll brighten my day. But please do complete those, and we really appreciate your time. And thank you for joining us. And thank you, Kevin and your team. Also, really appreciate you coming in to share your offerings. And I also want to put in the plug too that they are really great people. So if you go to them with a question, their answer may actually be, hey, our service isn't perfect for you, but thanks for letting us know what we should work on next. But, you know, maybe consider a local option, or maybe there are others. So while yes, they do work for AWS, their goal is to help researchers. And I do firmly believe that, at least from Kevin and the team that are here, that they genuinely want to help the research, not just sell their product.